Hello, friends. Welcome to topic 2, lesson 1. Today we're going to look at adding rational numbers. And rational numbers is a fancy math term that basically means a number can be rewritten as a fraction in A over B form. So rational numbers include decimal numbers, fractions, obviously, improper fractions, mixed numbers, and even integers, which, if you recall, are our positive and negative whole numbers. Those can all be written in fractional form. So today we're going to look at adding rational numbers, and you're actually going to have to remember some of our rules from topic 1 in order to be successful here today, right? You're really not learning anything new. We're just going to apply some things that we've already talked about. And in topic 1, we talked about when we're adding, if the signs are the same, then we're going to add those two numbers together and keep the sign. Or if the signs were different, we actually needed to subtract those two numbers and then keep the sign from the number that was furthest from 0. So if we look at the decimals here, we can see that 4.53 plus negative 15.2, those signs are different. So I am actually going to subtract right now 15.2 minus 4.53. And of course, I need to add a 0 here in order to subtract properly. If I have 0, I cannot take away 3. So all of your rules about borrowing or trading are still going to apply here. 10 take away 3 is 7. If I have 1, I cannot take away 5, so I have to borrow from the 1's place here. That's going to become a 4. He's going to become 11. That leaves me with 6. Decimal comes straight down, just like we learned in topic 0. And 4 minus 4 is 0, and 1 minus 0 is 1. So the numerical value for our answer is 10.67. And now we need to understand that negative 15.2 is further away from 0 than 4 and 53 hundredths, or 4.53. So we need to make sure that we understand that that final answer is going to be a negative number. If we look at the fractional problem, negative 2/5 plus negative 1/3, I can see when I read that problem out loud to myself that those signs are the same. So I'm actually going to combine these two fractions and then make them negative. All of the rules that we learned about fractions in topic 0 still apply, right? So if 2/5 plus 1/3, I still need to find a common denominator, which in this case is going to be 15. And I've had discussions with some of you about finding patterns here, right? How did I go from a denominator of 5 to a denominator of 15? I multiplied by 3. In order to keep things equivalent or balanced, I then have to multiply the 2 by 3, so that's going to give me 6/15. And same thinking, different numbers here on the other side. 1/3, again, if I denominator from 3 to 15, I did times 5. So that means I need to do the numerator of 1 times 5, which is going to give me 5, of course. 2/5 is the same as 6/15. 1/3 is the same as 5/15. I'm going to add them, which is going to give me 11/15. And then since both of those fractions in the original problem were negative, I'm going to keep the sign, which makes this answer going to be worth negative 11/15. Got to make sure we understand how to work with fractions, and we still have to be able to apply those integer rules from topic 1. If we look at the mixed numbers problem, negative 4 2/3 plus 5 1/8, I know that at some point I'm going to have to do some subtracting because those signs are different, but I've got to do a lot of setup work here before I even get to the subtracting. So I like to convert my mixed numbers into improper fractions. So negative 4 2/3 is really going to be negative 14 over 3. Plus 5 1/8 is going to be 41 over 8. Recall from some of our earlier units. Now I have two fractions. And again, anytime I have fractions, I have to have common denominators. So for me, the common denominator for 3 and 8 is going to be 24. So I know that if I multiply 3 times 8, I'm going to get 24, which means I need to multiply the negative 14 by 8, which is going to give me negative 112. Negative 14 over 3 is the same as negative 112 over 24. And same questions, new numbers on the other side. How did I go from 8 to 24? And of course, that was times 3. So I must do 41 times 3, which is going to give me 123. So 41 over 8 is equivalent to 123 over 24. Still adding these fractions currently, right? Since the signs are the same, I am actually going to subtract these two. So again, 123 minus 112 is going to give me 11. And I'm going to put that 11 over the denominator, which is 24. And since 5 and 1/8 is further from 0 than negative 4 and 2/3, my final answer is going to remain positive. Go ahead and pause the video. Try an example of the decimal, the fraction, and the mixed number on your own to see how you do. Make sure if you have any questions that you please raise your hand and clarify. Here are the answers for each of the problems that you should have done on your own. I tried to explain why I was subtracting, even though it is an addition problem. And I tried to explain why the answer might be positive or negative. If you have any questions, again, please, please, please make sure you are asking. This is going to be something that we see throughout the rest of the school year.